We're going to try and do an experiment today. It's called the gallium beating heart. So it's quite a cool experiment. You take some molten gallium and then you submerge it, or you put it underneath a layer of sulfuric acid. The sulfuric acid reacts with the gallium to form gallium sulfate, and it changes the surface tension. So it all pulls up into a ball and then relaxes. And there's this really neat oscillating reaction where you get sulfate on the surface or no sulfate on the surface. So you see big changes in surface tension, and the piece of gallium is seen to beat like a heart. So we thought we'd try that today with a little bit of gallium, which I'm trying to melt in my hand. Small nugget of gallium, and you can see if I tap it on the hot plate, it's real metal. So now we're going to try and melt it, hopefully in my hand. So if I stand and hold it for long enough, in theory, the temperature should come from my hand, the heat should come from my hand, so it should melt the gallium, and then eventually we should have a small amount of liquid. So gallium, you can form an amalgam with this material, with all sorts of other materials like indium and tin. And in fact, indium, tin and gallium is used as the material inside many thermometers, which are used in the medical industry, because it's not as toxic as mercury, which was traditionally used. You may have heard of Mandela. He was the guy that sort of conceived or brought together the periodic table. And at the time that he did this, in about 1870, gallium hadn't been discovered. So he predicted its chemical and physical properties, and he called it Eka aluminium. Approximately 5 years after that, it was found using a spectroscope. So now we see it's melted. It looks just like a little ball of mercury rolling around on my hand. You can see the thick skin that has developed, the surface tension, causing it to form such a beautiful bulb. We're going to take our molten gallium and we're going to put it underneath a layer of dilute sulfuric acid, about the same strength as battery acid. So now we're going to make the acid, and to do that we're going to dilute concentrated sulfuric acid with water. This is the gallium that we melted on our hand. Now let's see what happens when we add the sulfuric acid. Wow, did you see that?
I did. What happened?
So the shape of the ball, or the lump of gallium, has changed because we've changed its surface properties. We've made gallium sulfate on the surface. The surface tension has got higher and it's pulled up into a nice ball. Okay, so that's the first step of the beating heart. What we've seen is the gallium, which was relaxed flat on the surface, has pulled up really quite sharply, and that's the first stage, or the in beat of the heart. Now we've got to make the heart relax. So what we're going to do is we're going to use dichromate. Dichromate's a fantastic oxidant, and we're going to put a small amount of it in and see what happens.
So gallium, I realise now, is named after France. It was discovered by a Frenchman, and its name comes from the old name for France, Gaul.
So what we're doing in this experiment is we're changing the surface tension, the gallium. So these are the forces that hold the liquid into either a ball or allow it to wet and flatten on the surface. So when the gallium is naked, okay, it's actually quite flat and it wets the surface. But when we put it under sulfuric acid, we form gallium sulfate on the surface. This increases the surface tension and then pulls the gallium so it's in a nice proud ball. What we then do is we dribble a small amount of dichromate solution in, which removes the sulfate from the surface and allows the gallium to go flat. And if we add the required amounts of dichromate to the amount of acid, then we can get the ball to flatten and come back up, flatten and come back up, so it looks like a beating heart.